Hello and welcome, geometers, to another lesson. This time we're looking at lesson 3 of Unit 7, the properties of parallelograms. If you have Mr. Forster's class, we actually went through quite a bit of this on Wednesday. And so if you haven't yet, please go check out the Desmos activity going over these properties. Let's go ahead and dive in. Starting off, defining what a parallelogram is. A parallelogram is a quadrilateral, which means it has 4 sides, with 2 pairs of opposite sides that are parallel. So to give a little sketch or example here, we can see here that this top side has 2 arrows along with the bottom side. So these 2 are sides that are opposite one another, are parallel. Also these 2 on the left and right side have 1 arrow. These 2 will also be parallel. Next, we can look at some of the properties of parallelograms that are interesting. The first one here is titled the parallelogram opposite sides theorem, which states that if we have a quadrilateral that is in fact a parallelogram, then opposite sides will be congruent. So let's walk through why this would be the case. And we're going to go through this proof here in number 3. Here it says that we are given this parallelogram ABCD. So this little box here, this means that this is a parallelogram. And our goal is to prove that AB, which is this side here, is congruent to CD over here, and that BC up top is congruent to DA. So let's go ahead and get started. Our first statement is we have parallelogram ABCD. That's the only thing that's given to us. Our usual first statement, or first reason rather, is the given. Next, we can use the definition of a parallelogram to make some claims. So we know that AB is parallel to CD. I'm going to go ahead and add that onto our diagram here. We also know that BC will be parallel to AD. And add that to our diagram as well. Next, we know that angle 1 will be congruent to angle 4, and angle 2 will be congruent to angle 3, because we have this transversal AC. So each of these pairs, 1 and 4 and 2 and 3, are alternate interior angles. Go ahead and add that to our diagram. So we know that 1 is congruent to 4. We also know that 2 is congruent to 3. Next, we can make the claim that AC is congruent to itself. This is sometimes called the no-duh property if you're in Mr. Forster's class. Formally, it's called the reflexive property. Add that to our diagram there. Next, in step 5, notice that we have 2 angles and the side that is sandwiched between them, which we would call the included side. Now you'll notice that we have triangle ABC. ABC, we can say is congruent to triangle CDA, based on the angle side angle congruence theorem. And because these triangles are congruent, that means that their corresponding parts will also be congruent, which we use CPC/TC. So we've proven that AB is going to be congruent to CD, BC is going to be congruent to DA, because those are the corresponding pieces of the 2 triangles, and the 2 triangles that we have are congruent. Next here, looking at number 4, ABCD is a parallelogram. So if we know this, we need to find the values of the variables, then find the lengths of the sides themselves. I want you to go ahead and try this on your own. Go ahead and pause the video, and I'll go through the solution here in a few seconds. All right, solving for y is where I'm going to start. And if I look over at my diagram, you'll notice that I've added these 2 tick marks because opposite sides will be congruent in a parallelogram. So I know that 3y and 6y minus 9 are the same. So I can set them equal to one another. If I subtract 6y from both sides, that leaves me with negative 3y is equal to negative 9. Just a note, this is not the only way to solve this. This is just the way that I happen to solve this. And y then would be equal to 3. Next, we're going to go ahead and solve for x. So if we look at our parallelogram again, I've got 2 brown tick marks here this time. So 2x plus 3 and 4x minus 5, again, are opposite sides, so they will be equal to one another, which means that I can set them equal with their expressions. If I subtract 2x from both sides, I'm left with 3 on the left side and 2x minus 5 on the right. Add 5 to both sides, and I'm left with 8 on the left and 2x on the right, which means that x is equal to 4. Now that we have the values for our variables, I'm going to take this y equals 3, this one right here, and I'm going to substitute that into the y in 3y. I'm going to choose this one because the expression is a little bit simpler, and since these two sides are equal to one another, I'm going to use the simpler expression. So I'm going to say, okay, I'm going to take 3 times the y value of 3 here. That means that this side right here has a length of 9, and so will this side over here. This will also have a length of 9. Next, I'm going to take this 4 that is equal to x, and I'm going to choose this top equation right here. To me, it's just a little bit simpler. You could use the bottom equation, but addition usually goes a little bit faster in my head than subtraction does, so I'm going to choose this one. So if I do 2 times 4, and then add 3, well, I know 2 times 4 is 8. That's 8 plus our 3. This means that this is a length of 11. And this will also have a length of 11 down on the bottom, because again, these two opposing sides are congruent. All right, moving on, we can look at some of the angle relationships as well, not just the sides. And we have this parallelogram opposite angles theorem that states if a quadrilateral is a parallelogram, then opposite angles are congruent. We talked about this a little bit in class. We kind of follow the diagonal. We'll see that here in a second. And then defining consecutive angles, which again we talked about a little bit in class if you have me for geometry. These are two angles that share a side. They kind of fall one right after another. If we look at number 7 for angles R and S, which are these two right here, they are consecutive angles of a parallelogram. These consecutive angles we found in class on, I believe it was Wednesday, are supplementary. They will add up to 180. And that comes from the nature of these opposite sides being parallel, and then this line SR being the transversal of ST and RW. So we have consecutive interior angles here, which are supplementary, just like we learned back in Unit 3. So let's go ahead and look at another way we could do this. We know that these two angles are going to be congruent because they're opposite one another, based on our opposite angles theorem. Well, I also know that S and W are going to be congruent, and if the whole thing has to add up to 360, then each pair of sides here, whether we look at left and right or top and bottom, have to add up to 180. So if I do 180 minus 112, that's going to give me 68 for these two angles that are left over at S and W. So this all put together gives us our parallelogram consecutive angles theorem, which states that if a quadrilateral is a parallelogram, then consecutive angles, angles that share a side, are supplementary. They add to 180. Next, looking up at number 9, we're given this parallelogram EFGH, and it says to find the value of y in this parallelogram. So we have these two angles given to us, and then to go through and find the measure of each angle, angle E, G, F, and H. So because these two angles, E and G, are opposite one another, they will be congruent. So I can set them equal to one another in my algebra expression, or equation rather here. If I do that, I can subtract 3y from both sides, which leaves me with 3y plus 4 now equals 37. From here, if I subtract 4 from each side, I'm left with 3y is equal to 33. And then if I divide by 3, I will get y is equal to 11. Now I can go through and actually plug this value back into my either of these to get angles E and G. So if I do that, I'm going to choose angle E here, which I know is 6y plus 4. And so if I substitute that 11 into the y, I get 6 times 11 plus 4, which gives me 66 plus 4 for the measure of angle E, which is a total of 70 degrees. Earlier, in the last slide, we said that opposite are congruent and consecutive are supplementary. So that means that if I look at angle F up here, that's consecutive to angle E, which will be supplementary to angle E. So I can subtract 70 from 180, and I get that the measure of angle F is 110. So I know that angle E is 70. I also know that angle G is 70 because it's opposite angle E. I here now have that F is 110, and since H is across from or opposite angle F, angle H will also be a measure of 110 degrees. All right, number 10, I want you to try on your own. Go ahead and pause the video and see if you can work through it. And I'll go through my solution here in a few seconds. All right, the first thing that I'm going to start with here, because these two angles both have the variable of x in them, is I know that angles A and B will add to 180 degrees because they're consecutive angles. So I'm going to set up my equation as 2x plus 10 plus 2x minus 10 is equal to 180. If I simplify this left-hand side, the 2x and the 2x here become this 4x, and I conveniently have positive and negative 10, which is going to leave 0 left over, so I don't have any constants left on this left side. Now, if I divide both sides by 4, I should get that x is equal to 45. So I've got x taken care of. Now I need to figure out what the value of y is. Notice that it doesn't ask me for the actual angle measurements, just the variables this time. So I'm going to use angle A here because angle A and angle C are congruent to one another. So if I know what angle A is, I can use that to solve for y using angle C. So I'm going to plug 45 into that expression. So 2 times 45 minus 10 gives me the measure of angle A. And if I do 2 times 45, I get 90. 90 minus 10 gives me 80 degrees. Now that I know that angle A has a measure of 80 degrees, I can set this expression for angle C equal to 80. So I'm going to do that. So I now know that y plus 20, which is this expression, is equal to my 80 from that congruent angle. And if I subtract 20 from both sides, I get y is equal to 60. All right, moving on to our last slide, a little bit more involved. Number 11, using our last theorem in our notes, says the parallelogram diagonals theorem. We also talked about this a little bit in my class on Wednesday, so I would highly recommend making sure that you see and go through that Desmos activity and watch the video if you missed class. The parallelogram diagonals theorem states that diagonals of a parallelogram will bisect each other. They meet at their respective midpoints. So what that means is, well, let's look at part A here. I'll do part A and then I'll have you try part B on your own. We're going to look at this and we're going to have to use a system of linear equations. If you have not gone through lesson 2, I would highly recommend going back and looking at lesson 2 because that's where we reviewed these systems. And we're going to solve for each of the variables here in part A. So in A, from our diagonal BD, because AC is the other diagonal and it is bisecting BD, that means that this point where my cursor is the midpoint, which means that x plus 1, this expression, will be equal to this expression y, or BE is equal to DE here. So I have y equals x plus 1 for my first equation. I can also think of BD as bisecting AC. So from AC, we have that AE, which is 3y minus 7, is equal to EC, which is 2x. So now I have these two equations, and I can use my system of linear equations methods to solve this system. I'm going to use substitution in this case. I know in class said that I typically prefer to use elimination, but substitution makes sense here because I already have y equals x plus 1. So I'm going to take this x plus 1 and I'm going to substitute it in where this y is. So here I have 3 times x plus 1 minus 7 is equal to 2x. Distributing that 3, I get 3x plus 3 minus 7 equals 2x. And then if I combine like terms, the 3 and the minus 7, I get 3x minus 4 is equal to 2x. If I subtract 3x from both sides, then I'm going to get that negative 4 is equal to negative x. 3x minus 3x, I've got no x's left on the left. 2 minus 3 is negative 1. And then if I divide by negative 1, I will get that x is equal to 4. Now that I have that x is equal to 4, if I want to solve the value of y, well, I can use either of these two equations. The first one seems to be the easier one to use, so I'm going to use that. So since y is equal to x plus 1, if I substitute the x equals 4 in, I get y equals 4 plus 1, and that gives me that y is equal to 5. So these are the two values of my variables, 4 and 5. All right, I want you to try part B on your own. Go ahead and pause the video and see if you can get all the way through, much like we did here, and then I'll go over my solution here in a few seconds. All right, much like last time, I'm going to start off with the information that we have. So from this diagonal, WY, I know that B plus 10 is equal to 2A minus 8. I also know from XZ that we have that 3A minus 1 here is going to be equal to 3B plus 2, again, because this, where my red dot here, is the midpoint for both of those diagonals. I'm going to, again, use substitution. If I subtract 10 from each side in my first equation, I get B is equal to 2A minus 18. And so now I can take this 2A minus 18 and I can substitute it into the B value in my second equation. So now if I do this, I'm going to have 3A minus 1 on the left, and then that 2A minus 18 is substituted in for B, so I have that times 3 and then add 2 on the right. When I distribute that 3, I get 6a minus 54. 3 times 2 is 6. 3 times 18 is 54. Everything else remains the same. Combining like terms on the left, I get 6a minus 52 on the right. Still 3a minus 1 on the left. Next, if I subtract 3a from both sides, I'm going to get negative 1 on the left, 3a minus 52 on the right. Add 52 to each side. My goal again is to isolate this variable a. And I'm left over with 51 on the left and 3a on the right. And then finally, if I divide by 3, I get a is equal to 17. So I filled in the first variable. Now, again, I can use this value in either of my original 2 equations to solve for b. I'm actually going to use my modified first equation because b is by itself already, so I'll have the least amount of work on this one. So since b is equal to 2a minus 18, if I substitute the 17 in, then I'm going to have 2 times 17 minus 18. And that's 34 minus 18. So 2 times 17 is 34. Take away 18. And that means that b is equal to 16. All right, that does it for lesson 3. Make sure to check in with Mr. Swatala or myself or whoever your geometry teacher is if you have any questions. We are more than happy to help out. If you are in my class or Mr. Swatala's class, you are more than likely going to be getting ready to take your quiz here in a few days. So keep an eye out for the review to get posted shortly after this video is available. And I hope you have a fantastic rest of your day, and I will catch you in the next one.